Hello everyone, I'm Gulnar, a PhD student in Human-Computer Interaction Group at UC Merced. Today, I will present our work using action-level metrics to report the performance of multi-step keyboards. Multi-step text entry methods are commonly used on devices with smaller screens to enter text in languages with large alphabets and complex writing systems, and as alternative input methods for accessibility. Unlike Qwerty, which is a uni-step and unambiguous method, multi-step methods are ambiguous as they require performing multiple actions simultaneously, called chorded method, or in a specific sequence called constructive method to produce an input. Twiddler is a chorded method where users press multiple keys at once, like playing a chord on a piano to enter one character. Morse code and multi-tap are constructive, where users press multiple keys in a specific sequence to enter one character. Traditional performance metrics are designed explicitly for non-ambiguous uni-step methods, like Qwerty, thus fail to capture the actual performance of multi-step method to help in design improvements. This table illustrates two attempts of entering the word quickly with Morse code. In the first attempt, L was replaced with J, then L was replaced with P. The conventional error rate yields the same results in both cases due to one character error, but the proposed unit error rate metric accounts for each action performed to enter the letters to give better measures for the attempts. It shows learning in the second attempt with minor improvements at action level. We present three new action-level performance metrics. Unit error rate represents the average number of errors committed by the user when entering one unit. A unit can be a character or a symbol. Unit accuracy is the opposite of unit error rate that represents the accuracy rate of a unit. We also propose a unit complexity metric that categorizes each action to enter a unit into different difficulty levels, represented by the continuous values from 0 to 1. We demonstrate the benefits of the new metrics in a study with one constructive and one chorded method. It used a counterbalanced within subject design with 5 sessions per method, where participants entered 10 pangrams per session to enable citing each letter of the English alphabet. For the constructive method, error rate dropped significantly from session 1 to 5. No such trend was observed for the chorded method. For the constructive method, unit error rate reduced from session 1 to session 5. Like error rate, no such trend was observed for the chorded method. Unit error rate per letter identified two groups of letters: not learned letters that were both difficult to enter and learn, and learned letters that were difficult to enter but easier to learn. There was a high inconsistency in unit accuracy across the not learned letters, but an upward trend was observed for the learned letters, indicating learning even in the last session. Here, the top 4 not learned and learned letters for the constructive method are highlighted in red and green respectively. A correlation can be seen between unit error rate and the time spent to enter these letters, suggesting a higher cognitive and motor effort to enter them. Evidently, participants frequently made errors entering the letters that require similar actions or repeated actions, such as multiple dots or dashes. Comparison between not learned and learned letters for the chorded method showed that unit accuracy was increasing for all learned letters, suggesting the accuracy of learning. Here, the top 4 not learned and learned letters for the chorded method are highlighted in red and green respectively. It too suggests a higher cognitive and motor effort to enter these letters. Evidently, chords that were composed of the keys closer to the boundaries were faster to enter than the other letters. Conventional metrics are effective in reporting the overall speed and accuracy, but action-level metrics can provide extra details about users' input actions. For designers, this additional insight is crucial for identifying a method's pain points to facilitating improvements via redesign or augmenting machine learning or language models. Thank you for your attention. We will appreciate your questions or comments on the work.